Alrighty, in this video, I'm going to be talking about inverse trig in terms of an introduction to inverse trig derivatives. And then in class, we'll talk about more derivatives and integrals. But here, I want you guys to think back when we did inverse trig back in Unit 1 at the very beginning of the semester, like the first week of class, inverse trig, where we drew a triangle to represent what each side meant. So here we have y is equal to inverse cosine of x, and we're going to let y be the angle measurement, or theta. Let's let this be y. And remember that cosine is going to be adjacent over hypotenuse. So I have my adjacent, then I have my hypotenuse. And then using good old Pythagorean theorem to find my side, which eventually I'll need sooner or later, I'm going to have a squared plus x squared is equal to 1 square. A squared is equal to 1 minus x squared. And a is equal to the square root of 1 minus x squared. Now, why do we need this? We'll find that out soon enough. All right, so the bottom part says find the derivative of inverse cosine. I don't know what the derivative of inverse cosine is right now. That's what we're trying to figure out. So what we are going to do, though, let's take the cosine of both sides so that I have cosine of y is equal to x. And then I'm going to use implicit differentiation on the left to get negative sine y dy dx is equal to 1. So dy dx is equal to negative 1 over sine of y. And notice how here, sine of y relates to my triangle right here. Based off of my triangle, remember that sine is opposite over hypotenuse. So I have opposite over hypotenuse. So that's just going to be 1 over, or negative 1, over my opposite, which is root 1 minus x squared. So this means that the derivative of inverse cosine is going to be negative 1 over the square root of 1 minus x squared. All right. We're going to do the same thing here where we are going to create a triangle that represents inverse sine. So once again, I'm going to draw my little triangle, have y be theta, and then I have opposite over hypotenuse. Now once again, because this is very similar where we have x as a base, that means that the square root of 1 minus x squared is going to be my other base, given that my hypotenuse is 1 right here. Now, that's going to be important because once we take the derivative of this, you'll realize that we don't know what inverse sine is. So we are going to take the sine of both sides so that it is easier for us to take the derivative of the left and the right using implicit. So that's going to give me cosine of y dy dx is equal to 1. Dy dx is going to be equal to 1 over cosine of y. And then we just got to figure out what cosine of y is. Well, remember that cosine is adjacent over hypotenuse. Adjacent hypotenuse. So here, the derivative of inverse sine is going to be very similar to the derivative of inverse cosine, except this one's positive. Whereas this one right here is negative. So pay careful attention to that. All right, now pause the video. What I want you to do is try to figure out and derive the derivative of inverse tangent using triangles, and then come back to the video and see if your work is correct. Remember that inverse tangent or tangent is opposite over adjacent. So we have opposite, adjacent, and then using our knowledge Pythagorean theorem, we're going to have x squared plus 1 squared is equal to c squared. And that's just going to give me x squared plus 1. I'm going to rewrite it a little bit so that it's prettier. In this case, 1 plus x squared. You could say x squared plus 1. I don't care. But either way, we don't know what inverse tangent is, the derivative of that. So we are going to take the tangent of both sides so that the inverse tangent goes away. Hopefully by now we know that the derivative of tangent of y is going to be secant square of y, and then dy dx is equal to 1. Dy dx is equal to 1 over secant square of y. Now remember that secant is going to be the reciprocal of cosine. So essentially, this is going to be the same thing as whatever cosine square of y is. Well, if I were to look at this, remember that cosine is going to be adjacent over hypotenuse. So we have adjacent, which is 1. And then my hypotenuse being square root of 1 plus x squared. Then since I have a square right here, I'm going to square that, which means that my derivative of inverse tangent is just going to be 1 over x squared plus 1, or 1 over 1 plus x squared. I don't care what you say. And that is going to be your inverse derivatives of sine, cosine, and tangent. And essentially the same thing happens with cotangent, cosecant, and secant. I'm not going to go over how to derive the derivatives of these. I'm just going to give you the formulas. And essentially, they're very similar to what you saw with the first three. So notice how here, inverse secant is going to have the negative, but then inverse cosecant is going to have the negative, and then inverse secant does not have the negative. Inverse cotangent is very similar, except this time it's negative. Go ahead and do 4 through 7, maybe, maybe not. I don't care because I think we'll do this in class anyways. So you could pause the video here and call it a day. Likewise, we'll talk about more of the inverse trig derivatives right here during class.